we now talk about algebra of functions. So we can add, subtract, divide and multiply two functions. So you can simply add the functions, say f and g are two functions, from some set A to real numbers. So these are real valued functions. So they land in real numbers. You can add them, you can subtract them, you can multiply these two functions, and you can divide them. Simple example, say f of x is x square and g of x is 2x plus 3. Then you can add them, you get x square plus 2x plus 3. You can subtract, you get x square minus 2x minus 3. You can multiply, so x square times 2x plus 3. You get 2x cubed plus 3x square. Or you could divide them. So fx by gx is x square over 2x plus 3. Now we want to talk about injective and surjective functions. So a function f from say x to y is 1 to 1 or injective if images of distinct elements of x under f are distinct. So what it means is it takes one element of x and precisely maps it to one element of y. So let us give an example. So say you have this x here and then you have y here. And say you have elements a, b, c here, and you have 1, 2, 3, 4, 5 here. So for an injective function, so say if f is injective, it will take one element here and map it to exactly one element here. So say it takes a and maps it to 1, it takes c and maps it to 5, it takes b and say maps it to 2. So this is an injective function. A function f is surjective or onto, so it is onto if every element of y is the image of some element of x. So we want to cover all elements of y, so all the elements where f lands into. So if every element of y is image of some element of x. So let us give an example. So again we will fix sets. So say you have set x and you have set y. So y has say two elements, say 11 and 12, and say there are three elements here, say p, q and r. So p and q both get mapped to 11 and r gets mapped to 12. So this is a surjective function because both elements of y are covered. So both these elements have a pre-image. So if every element of y is the image of some element of x, so both these elements 11 and 12 are images of some elements of x. So in other words, all elements of y have a pre-image in x. So this is the image. So all elements of y have a pre-image. So they have a pre-image here. On the other hand, this is not surjective or not onto, because you have these two elements 3 and 4 here, and this 3 and 4, so 3 and 4 do not have pre-image. So they have no element in x which maps to them. So this is not onto. So this is not onto, whereas this is onto. Now you could have a case whereby the function is neither 1 to 1 nor onto. So let us construct another function which is neither 1 to 1 nor onto. So this can be easily done. So say I will construct a new function now. So say you put another element d here. This d also maps say to 5. Now if you have this another d here mapping to 5, this function is no longer 1 to 1. Why? Because distinct elements here should map to distinct elements here. Here C and D are different elements, but they map to same element 5 here. So this map is no longer 1 to 1. It is also not onto, because again 3 and 4 do not have a pre-image. So 3 and 4 do not have a pre-image. So now this, what I have drawn, is neither 1 to 1 nor onto. So this is neither 1 to 1 nor onto. So let us give some examples. So for example, the identity function is both 1 to 1 and onto. So identity function, you know, is nothing but f going from real numbers to real numbers, and f of x is just x. So another example, say f of x is equal to x square. This is neither 1 to 1 nor onto. So it is not 1 to 1 because you take 1 and minus 1. These are two distinct elements, and both of them get mapped to 1. Yeah, because 1 square is 1 and minus 1 square is also 1. So there are two distinct elements getting mapped to a single element. Therefore this is not 1 to 1. It is also not onto because we have x square here. So here there are elements like minus 1 in real numbers. So we have the domain as the entire real numbers. So actually let us quickly draw the graph, and that will make it clear. So you have x-axis here, you have y-axis here, and this is the parabola. So this y-axis is the codomain or the range. So in the range you also have functions like, in the range you have members like minus 1. So this minus 1 has no pre-image in x. So there is nothing in this entire x-axis which gets mapped to minus 1. So this minus 1 does not have a pre-image. So it is not onto. Now we can modify this to make it at least onto. So you have all these extra elements here in the negative y-axis which do not have pre-images. So we just modify this function and say that, you know, this codomain is restricted to only positive real axis. So we do not consider this. We say the codomain is restricted only to positive real axis. So in that case, so you have the codomain restricted to positive real axis. In that case, this function is onto. Now everything which is positive will have a square root, and in fact it will have a plus square root and a minus square root, and that will make the function onto. But it is still not 1 to 1 because again 1 and minus 1 will still get mapped to 1. Now consider another function, the identity function, but it goes from natural numbers to integers. So it takes 1 to 1, 2 to 2, and so on. Now this is 1 to 1 but not onto, because minus 1 is an integer. So it lies in z, but it does not have a pre-image. So there is no pre-image of minus 1 in natural numbers under this identity function. So therefore this is not onto.